You're welcome once again to our lectures on inorganic chemistry. We had started the study of coordination compounds. Today we want to review the nomenclature of coordination compounds. At the end of this slide of this show, you will have a link to enable you view the PDF format. The link is at the end of this presentation. For the purposes of making it easy for anywhere across the globe to understand the exact compound you are talking about, the International Union of Pure and Applied Chemistry, IUPAC, published rules that is aimed at systematic naming of coordination compound. Among such rules is one, that coordination compound is named with the positive or cations first before the negative component of the compound. As you can see, in K2FeCN6-, this compound is referred to as potassium hexacyanoate ferret 3. It is called ferret 3 here because ferret is referring to iron in the Latin perspective. And you realize that there are 6 units of cyanide attached to iron. Therefore, 3 out of the 6 will neutralize the 3 positive charges of iron, and 2 of potassium takes the remaining 3. Therefore, the resultant coordination compound has a minus sign, and you have the name ferret, meaning that the resultant compound is negative because the compound is made up of 2K, as you can see, and 6 cyanide having 3 negative charges. Further on, the ligand is named first and in alphabetical order. We must mind the fact that when we talk of alphabetical order, we do not include the prefixes that indicate the number of such ligands attached to the central metal atom, such as di, tetra, or tri, as in dichloro, tetraamine. The di and the tetra do not count, but what comes first here is the amine before the chloro, as you have in tetraamine dichlorocobalt 3. And you also have in triamine aquo-bromo chlorocobalt 3. That is to say, there are 3 amine unit attached to the cobalt and 1 water unit attached to the cobalt. Then you have the bromo and the chloro. Then ends with the oxidation state of the metal in Roman numerals. As you saw, we wrote 3 in Roman numerals in the bracket. For us to continue, we have to look at the names of the ligands and the metal that make up the coordination compound. First among them is the ammonia group, which we call the amine group. Some people write it with double M, some write it with single M, amine. Water molecule is known as aqua or aquo. The bromine, bromo, chloro, cyano, hydrido, nitrio, while the metal centers maintain their names if the resultant complex is neutral or cationic, but ends with ate if the resultant complex is negative, as we saw above. Further on, we wish to name diamine dichloropplatinum 2. Diamine dichloropplatinum 2. You can see the 2 green chloride ion and the 2 amine attached in a cis position, and this shows a square planar geometry. Further on, we have tetra-aquo-nickel 2. Tetra-aquo-nickel 2, telling us that there are 4 molecules of water attached to one atom of nickel. And because water is neutral, the two positive charges of the cation of nickel remains, and this shows a tetrahedral geometry. You also have a compound of copper where you have chloride, bromide, and four amine group attached to show an octahedral structure. Therefore, we request that you name that compound. For purposes of getting the PDF format of this presentation, we encourage you to copy the link below and paste in your search engine, and you will have the PDF link. Thank you.